On exercise 7A, translations. Now this first bracket represents coordinates. That's what it represents. This is your coordinate xy on a Cartesian plane. So you've got an x-axis and y-axis, and you don't know what x is, you don't know what y is. Now, the arrow, which we learned to mean maps onto, or becomes, or transforms to, right? We're saying this xy coordinate becomes this new x and y coordinate. Now notice I've color-coded the plus h and plus k, because I would try to get you to understand that what I'm doing here, when I say plus h, I'm actually saying whatever the x-coordinate is, I'm only adding to the x-coordinate. Over here, I'm saying whatever the y-coordinate is, I'm going to add or subtract to the y-coordinates. Now an example would be, if you look at this graph over here, let's say I start at 3, 2. I've got a coordinate, 3, 2. So x is 3, y is 2. And then I want to move this horizontally. I want to move that particular coordinate to 6, 2. What has changed? What has changed and what hasn't changed? The x value has changed. I went from 3 to 6. Now, if you think about it, this is how I would write it. I would say I went from 3, 2 to 6, 2. Okay, so 3, 2 to 6, 2. Now, the y values haven't changed, but from 3 to 6, it has changed. So what I'm doing is I've changed the x values. Now, what did I do to change it? Plus 3. Plus 3. So logically, what I've done here is I've said, from 3, that's my original value, that's my original x-coordinate. I'm adding on 3 to change the x values to become 6. And I'm adding 0 to the y values so that it stays the same. Okay?
Why should we with y then?
Oh, you're right. Thank you.
And you write 6, like you write the answers to it, or you write plus something?
No, you're right. 6. I'm just showing you the process. I'm showing you the process as to the logic for it. Because eventually what I want you to understand is, this represents the 3, which is your original 3 that you start off with, and you moved across 3, that red 3 there is what you're translating. What we've done is we've moved across to the right by 3 units. So we call that translation. Okay? So what I've done here is I've just said translate by 3 units in the x-axis direction. Another way of thinking about it is I just said move to the right by 3. Okay? So this is saying move to the right by 3. Now notice the notation I'm writing here. That's what I want you to copy here. What's the x dash? Copy it down and stop saying what the heck. Copy down. Yeah? Well, everything, just everything, but I'm just saying this is the main part that I want you to understand. What I'm doing here is I'm saying to get the new coordinates, which we use a dash or prime to say that this is the new x coordinate. This is the old x coordinate. And the old x coordinate is whatever x is. Now, x could be 3, x could be -1, x could be -2. Okay? Well, what I'm doing here is I'm just saying for every x coordinate, if I just want to move to the right by 3, take the original, add 3. So original, add 3 is what I'm trying to say. Okay, so I'm trying to say this means original x value, add 3 units will give you the new x value. That's all I'm trying to say. I'm just trying to say x dash means to get the new, which is 6. This is the original, 3. 3 plus 3 gives you 6. Okay? Now, if you look at the y values, how we say it, we say that you've got y dash, which is the new y. What am I doing in this case? I'm adding 0. It means that I'm not moving it up or down. Because if you affect your y values, if you add 1 to the y, it moves in the y direction. If you subtract 1, it moves the coordinates down. So if I subtract 2 by 1, it drops it down to 3, 1. So what the y function, or what this is responsible for, is it moves up or down. Okay, so what I'm trying to say is at the final end of it, we can say one thing. We can say this means translation of 3 units to the right. That's what it means. It just means if I'm adding to the x, I'm moving to the right. If I'm subtracting the x, I'm moving to the left. If I'm adding the y coordinates, then I'm moving up. If I'm subtracting the y coordinates, I'm moving down. Okay, so that's all I'm trying to say. But you just got to get used to the notation. So in your textbook, this is what it looks like. In your textbook, you'll say x, y coordinates become x plus h y plus k, because these are the new coordinates. We use x dash to say that's the new x, that's the new y. Okay, new y coordinates, new x coordinates. How do you get to the new? Add h to the x. How do you get to the new? Add k to the y. Does that make sense so far? Yeah, I'm just describing the notation. Okay? Now, if I gave you this one now, let's look at this notation here. This is your equation. It's a quadratic equation, y equals x squared. This is my notation. I've got x, y, so any coordinates on the quadratic, every coordinate, I'm going to add 2 to every x value, and I'm going to minus 1 to every y value. What transformation have I made? What kind of translation have I made so far? If every x coordinate is added by 2, what does this mean? 2 to the right. It just means that every x coordinate, if I add 2, I've shifted the graph across by 2. All the coordinates move to the right by 2. So here means right by 2. What does y minus 1 imply then? Down by 1. It means that every y coordinate, I'm going to subtract 1. So wherever the graph goes, I'm going to subtract 1 for every y value. They all go down 1. Okay, so that's what I'm trying to say. So if you were to read that transformation is, you're right, translates 2 units to the right, translates 1 unit down. Now you know how I taught you previously, I said just memorize what I taught you? I'm showing you the how now. I'm showing you how it all works. So we're going to use what we've just learned. This is what we've learned. We said, how do you get the new x value? Add 2 to the original. So move 2 to the right. And that will give you the new. If you want to find the y value, the new y value is made by subtracting every original by 1. That will give you the new y value. So that makes sense. Now here's the thing. Your equation is currently y equals to x squared. Okay, so, whoops, not that one. Your equation right now is y equals to x squared. What this means is for every original x value, you square it. That will give you the original y. But if you want the new equation, you want an equation where you have 2 to the right and then down by 1. What's the equation? How do you find that out, right? Then what you need is you need the new x and the new y. That has to represent the new equation. So this is what I need. I need to replace the old x and replace the old y with the new x and new y. So how do you do that? Rearrange it so you can replace the old x and replace the old y. This is what I mean. See over here? This is your original x. Original x plus 2 gives you new. If I want to know how to get the original x, then get the new, subtract 2. So if I minus 2 on both sides, I get new, take away 2 will give me the old. Now this is nice, because that means I can replace the old x with the new x minus 2. That gives me a new equation. Remember, you want the new equation. You don't want the old equation. This is the old equation. You want a new equation. So it means you need that the new x. We call x dash. Okay? And the same thing here, that's an original y. We don't want an original y. We want the new y. What's the new equation for the new y coordinates? So, how do you replace that? Same thing. Rearrange the y values over here. And you say, well, if I add 1 on both sides, take the new, add 1, gives me the old. Now, why do I do that? Because if you look on this side now, you can do this. You can say, all right, that's y equals x squared. I can replace, since y equals that and x equals this, I can replace it and say this. See what I've done? This is the technique, and this is why when I taught you in term 1 and term 2, I just taught you to memorize it. I didn't teach you the full technique to it. I just said, do this. This is how you know it goes up or down. This is where it all comes about. See here, this is your new equation. New y values, add 1 should give you the new y values, or the old y values, equivalent. Okay? What's the equivalent of the old? Take the new ones, subtract 2, that gives you the equivalent of the old. Now what you have here is an equation. This is your new quadratic equation that does what you want. You said you want to move 2 to the right, down by 1. This is the new equation. Now, normally when you write your equations, it's always y equals to something, not y plus 1. So I need to remove this plus 1 here. Opposite of plus 1, minus 1 both sides. So if I minus 1 both sides now, I'll say minus 1, This is what I taught you last term. Oh, yeah, not last term. Last term and this term. Remember how I told you? If it's -1, I say up, down. That's right. And you guys were able to read this. You do it really well in chapter 5. You're like, -1 means down 1. How did I know that? Because that was from here. That was -1, and I went through all this process. And instead of teaching you this process, I just said memorize it. I said if it's on the outside, -1 goes down 1. Remember how I said when it's x -2, I said how do you know it moves left or right? I said let it equal 0. The reason why I told you to let it equal 0 is because I didn't want you to get confused with x dash. So instead of telling you to say let it equal to x dash, I said let it equal to 0, and you solve for it. But what I was trying to teach you to do was move backwards. I was trying to say let this equal 0, so when you solve for x, you're actually going backwards. You're going x dash -2, which is over here. If that was equal to 0, you would have added 2 on both sides, and then you know what x dash is. That's why. Okay, so when I taught you guys to do it, I didn't get you to understand why, but the logic is here. You're saying every x, y coordinate, you get the new x and the x, y, add the original by 2, that means to the right by 2. Every original y take away 1, means go down 1. But if I go through the process, this is to get the new original add 2. This is to get the new original -1. I took away the dashes because that's normally the equation we see, but that's the one that you are meant to understand, that this is the new equation to represent that transformation. Okay? But when you type in your calculator, that will sketch moving to the right by 2, down by 1. This is the logic. Okay, now you're going to do this again in year 12, so you want to learn this really well because next year it's going to be more fast-paced, and the better you understand it now, the easier it is next year. Okay, so in term 1, we'll be going through all this again. Transformation chapter 3, we'll do the same things over and over. So if you can try to understand the technique I'm showing you, old x equals x +2 equal the new. Rearrange to get the old x because you want to replace all of the x's and the older y's with the new y's and the new x's. That's what you want. You want the new equation. You want to know what the new transformation equation is. So you've got to rearrange to do that. It gets confusing next year because you're going to move back and forth. You're going to go from like moving new to new, and new to old, and old to new. So that's why it gets confusing. So if you try to understand x dash means new, original x means the first equation. Okay? All right, let's try another example just so you get used to this idea. Let's try another one. This is from your example. Now let's read it. Yeah, just take your time. It says, find the equation of the image of the curve with the equation. That was a big sentence for saying that's a curve. I want you to find the new equation. This is your old equation. I want you to find the new equation if you translate 3 units in the positive direction of the x-axis. What does that mean? Right 3. So this just means I want you to move to the right by 3. So this says right by 3. Okay, and then it says 2 units in the negative direction of the y-axis. What does that mean? -2 means down 2. So, all it's really trying to say to you is I want you to move 3 to the right. I want you to move 2 down for this graph here. So this is a hyperbola, rectangle hyperbola. Okay, we're not sketching yet. In your exercise you will. But all you're needing to do now is your rectangular hyperbola. We want to move to the right by 2, right by 3 and down by 2. So the question is, how do you find the new equation? Now last chapter I taught you how to just work it out, but I want you to now do the algebra to get there. Okay, so same thing. Here's my notation. Copy that down. So I want 3 units to the right. So how do I do that? Every x add 3 will move to the right. Because I'm saying every x coordinate, add an extra 3 to it, so it moves to the right. Every y coordinate, subtract 2. So that will make the y values go down. So I'm subtracting 2 from it. How do we start off the equation again? I want to find the equation. Remember, this is your equation. This is your original equation. Your old x and your old y. You got y equals to 1 on x. That's the function. Yeah? So f of x, I'm just writing y to make it easier for you to see. But f of x is your y. What you need to do is to find the new equation. You need the new x and the new y. So I need to replace the x, I need to replace the y. What do I do? How do I replace the x and how do I replace the y? I want it all in terms of new x and new y's. What do you have to do first? Yasmin? Not sure. What do? I want to replace this x. I don't want the old x. I want the new y's. How can I replace it, Finn? Very good. Because remember, this means to get to the new x, you just have to take your original, so that's your original x, at 3. So if you were to write your notations, this is what it is. You say, to get the new, add, 3, sorry. That should be 3. Add 3 to get to your new. Same thing with this one. To get to your new, for the y values, you would say, oh my god, did I get it all mixed up? Okay, here we go. -2. Okay? So what we're saying here is we're saying to get the new, you have to take your original -2. So original -2 will give you your new. Now, I can't replace this with these x and y's because this is the original y. This is the original x. So what you have to do is rearrange this. Find out what the original y equals to. Find out what the original, like, the very beginning. How do you find the old y? So if you rearrange this, add 2 on both sides, you will get y dash plus 2 equals original y. Does that make sense so far what I'm doing? Yeah, so are we understanding? I'm just saying that's the new y, old y -2. I don't want new y here. I want original y, so I can replace original y. These y's have to match. That's original y, that's original y. So original y now equals to new y plus 2. So that's what I'm going to do. I'm going to replace that old y. Okay, same thing with your x values. I need to know what the original x equals to. So I'm going to rearrange this. Original x will equal to x dash -3. And you can see if I go through the algebra, this will now be y dash add 2 equals to 1 over x dash -3. Okay, see what I'm doing now? I'm just replacing original y, new y plus 2. So new y plus 2 equals original y. Original x, new x -3, which is what I had over here. New x -3 gives the original. Yeah? Rewrite your equation. Y dash equals to 1 over x dash -3 -2. And this is what I taught you in chapter 5. So in chapter 5, if I asked you, is this graph moving up, down, left, or right? You would have said -2 means down 2. And you would have noticed that x -3 tells you to the right by 3. And that's what I've been teaching you to memorize, but I haven't taught you the algebra to it. Now I'm showing you the algebra, why it works. Because once you understand that, you can then do dilations and reflections. You won't get it wrong with that. Okay, so you need to know the algebra to do it correctly. What I taught you was just to help you through chapter 4, chapter 6, and chapter 5, sketching. But after that, you need to be able to do the algebra so that you can get the harder ones. Okay? But you still need your basic skills. You should be able to read left, right, up, down. Those will really help you to sketch the graphs. How do we feel with that? Pretty good? All right. All right, here we go. Let's do some practice. Don't worry about this yet. I'm just going to get you to have a look at... Actually, I'll make up one. I'll make up one right now. Okay, let's say I gave you y equals to root of x. I want you to copy this example down and you guys are going to do it and we're going to check the answers, yeah? We've got y equals to root x. What I want you to do is your transformation. I want you to move to the right. Actually, I'll make it left. Move it to the left by 1. And I want you to move up by 7. I want you to find me the new x and new y coordinates using the algebra. Okay, so I want you to make it the new x, new y using the techniques I just taught you. Okay, so have a go with this one. I'll give you about probably 2.5 minutes. And then just one last slide before we finish today's session on function notation. That's what I want to do. Left 1 and up 7. What's the new equation using the algebra? Just put the answer. It's just that in the exam, do have the exam.
The questions won't be easy, but they'll have it's always the dilation of the students. If you know the technique, then fine.
But no, it's normally done. I normally do. Okay, X dash, Y dash. So how do I get write out the sequence first? Original X, how do I move it to the left by 1? Original Y, how do I move it up by 7? Find out the new X, find out the new Y, replace the original. Replace the original, that's the key. Replace the original. Who's on sport?
I'll just find it out.
Did you say something? No. All right, let's check your answers. Hopefully, you want it to move left by 1. It should be original X minus 1. So all X values minus 1 will make it move to the left. All Y values add 7 will move it up by 7. What you should have wrote here is new X is original minus 1. New Y is original add 7. Your job is to replace the original Y and original X. So you have to rearrange that. So I'm going to find original X, which is X dash plus 1. That's original X. Original Y, we have Y dash minus 7. Now, this is your equation. So you should have got these steps. Hands up if you got those 2 steps. Yes? Those 2 steps? Good? Okay. Now we want to replace that original Y. See, we said Y equals to new Y minus 7. So that's what I'm going to replace. The original X I'm going to replace with X dash plus 1 because that's what it's equivalent to. So if I replace that, is what you have now. You got Y dash minus 7, X dash plus 1. See what I'm doing there? That's what I'm doing. I'm just replacing original X, original Y. Rearrange the equation. So you get Y by itself, and you should get that. Hands up if you got this answer. Very good. That's transformations. That's doing transformations, yeah? You're learning to replace, and that's how you get it. That's why that plus 7 is up 7. X dash plus 1 will move to the left by 1. Because that's what you wanted. That's what you said here. That's what you get. Okay? Okay. Now, just one last slide, and I want you to copy this one down as well. The last slide is now only tricky because you use function notation, so you just got to get used to the language. Okay, so copy this one down. Here we go. Let's say if you had y equals to f of x equals to x squared. Yeah, I know it looks a bit funny there. All I'm saying is f of x is your y values. When I say f of 1, if I ask you what f of 1 means, what does it mean when I have f bracket 1 bracket? What does that mean again?
All values of x are equal.
Yeah, all this means is I'm going to substitute x equals 1 into the equation. That's all it means. So logically, all I'm saying is instead of x squared, it is now 1 squared. 1 squared equals to 1. Now, it's the same thing if I did this for you. So don't get confused, like this was part of your SAC as well. But if I gave you f of x plus 1, that means exactly the same thing. See, f of 1 meant sub 1 in. Then f of x plus 1 means sub x plus 1 into x. You're just replacing that. That's all it means. You're just replacing it. So, this is what you should have. Now, if I ask you, what does that do to the graph? If you have x plus 1 all squared, it moves left 1. That's what I taught you. So for chapter 4, chapter 5, chapter 6, I taught you how to read it. That means move to left 1. Now, so function notation-wise, f of x plus 1, doesn't matter what this equation is. That could be in any equation, doesn't matter. F of x plus 1 means left 1. Okay, so that's the logic. If you sub it in, that's going to mean left by 1. That's what you've been doing. Yeah? So when we say f of x plus 1, I just want you to understand this actually means left 1. Okay? If I gave you now f of x minus 2. See now f of x minus 2, but what's f of x? I told you it's x squared. So if I replace the f of x, instead of f of x here, I'm going to say it's x squared. Because that's what it says. F of x equals x squared. X squared minus 2. Now let me ask you, what does the minus 2 on the outside do? What's the minus 2? X squared minus 2. What's the minus 2 do? Goes down 2. So this notation here means down 2. So what I'm trying to say is, you know how we were doing the brackets before? We did xy, x bracket y to x plus 1, x minus 1, and y minus 2. You don't have to do that anymore. See, it takes too long to write this. It's easier to say f of x plus 1, that means left 1. It's easier to say f of x minus 2, down 2, instead of doing this way. Okay, so this is called function notation or transformation. This is the basic knowledge of transformation. Okay? Now let's test your understanding. Here we go. Let's try this one. I'm going to ask each and every one of you. If you've got f of x equals to x squared, what does f of x minus 1 mean? Can I please have, let's go with Anna. What does f of x minus 1 mean? Am I moving left, right, up, down? What am I doing? Good. This means right by 1. Fantastic is what you're substituting in. Yeah, so you're substituting the x squared to become x minus 1 squared. If you were to read that, you would tell me it's right by 1. Okay? Next one. B. What about if I had f of x plus 1? What does that tell me, Charlotte? Good. This tells me up 1 unit. Next one. C. Anne. What does f of x plus 3 mean? Very good. This actually means left 3, because essentially you're really just doing x plus 3 squared. And that just means, if you were to read that from what I taught you in chapter 5, it means to the left by 3. Let x plus 3 equal to 0. Solve for x. Okay? Next one, D. Trent. What does f of x minus 3 mean?
Down 3 units.
Good. This means down 3 units. What about E? If I had E, Ian. 1 left. Very good. 1 to the left. So left by 1. And finally F. What is that, Hamish? Down 1. Very good. Okay. Now each of the questions, I actually want you to sketch the graph. But I want you to read the transformations first. Okay, the better you can read it, the easier it is to sketch afterwards. Okay, and your chapter 5 was really good, so you should pick up this really easily. But that's exercise 7A, translations. Left, right, to learn the algebra and learn function notation is what I want you to do. Cool, that's all for today. And I'll call up your name and you can get your exam. Okay? Here we go, exercise 7A. Have a go with that one. Practice your skills. And next term, unit 2, we're going to aim for a better average. That's what we're going to do. Worse than my 6 years, just think of it that way. But at the same time, you guys also improved a lot too. So we started low, and we're slowly moving up. So hopefully unit 2, fingers crossed, I'll do you guys well. Anyway, Charlotte, exam. You can have it back. Remember Wednesday? Keep this on to Wednesday. We're going through it on Wednesday. You can take it home, have a look at it. I've put it into exam 1, exam 2, and your overall percentage. Najma. So E1 means exam 1. E2 means exam 2. Felix, not here. Ryan's not here. Yasmin. Matt.
Steph. Ben.
Ready, I fail.
Olympia. Rachel. Hamish.
That's actually above the Q3 is 74. We're average. You're well
And Anna. Finn. Akita. Lucy. Lauren. Did I say that? Seb. Oh, Seb's not here. Will's not here. Trent. Oscar.
Oh shit, I failed.
Ian.
Damn. Oh man, I'm gonna have to repeat your 11 man.
Sydney's not here. Simone. And Meredith.
Literally just multiple years.
We did better in exam 1, so theoretically you guys are good. Exam 2, CAS work is what we need to improve on. CAS work and applications. That's probably what let you guys down, but other than that, exam 1 was good. Exam 1 was much better.
We can improve the exam 2 amount.
Just go with
Bring it on Wednesday. We need it on Wednesday. I'm going to go through the solutions on Wednesday.
Look, I made notes to myself. Yeah, I guess What is that issue over there?
What did you get
Nah, you did all right. You did good. You picked up. There's still areas of improvement, but we all picked up. I think it was 90 marks in total. Oh, I don't remember.
Yeah, so out of what mark? Yeah. You start at 100. So if you max it up, then you get 100%, right? Because you only lose mark, yeah. It's like CT, you didn't mark.
Some of the questions I lost marks because my calculator stopped giving me the completing the square. Like it worked once and then it stopped working.
All right, show me.
So
So we can rectify that as well.
no, and it's weird because it's not even like it worked once. So I don't know what I suddenly stopped doing.
Normally it's a comma X. Most students forget a comma X on each occasion. Okay. Let's say I gave you so number. I mean, no, it's not that one. Algebra. Completing the square. If you did, let's say, x squared minus 5 times x plus 17, okay? Then you just got to make sure to put a comma x at the end, and then close brackets, and it should be able to do it for you. If you want it in exact values as well, then you just got to make sure your settings, so document settings, and you change the calculation mode instead of approximate. put exact. So exact, and that will change it to fractions. Because most of the time in the exam, you want to leave it in a fraction. And then they can do that for you. So I'm assuming it's a comma x.
Yeah, probably.
Same thing with factorizing. Sometimes if you don't put the comma x, they can't factorize it. The comma x will tell them, I want you to factorize with respect to this.
Why is the initial population 250? I don't really get.
Because you found c is 50, right?
Yeah.
Now initial means at the very start. So that means
Is that
the t
0?
So when t is 0, 0 minus 10, negative 10 squared is 100. 100 times 2.
Stupid.
Okay.
Well, the reason why I do that would really be fractional.
I was like, okay, I can't simplify this anymore. So, if I had to make it bigger to make it smaller, the rest.
Well, yeah, also, but you make this even more, right? If I ever start resting on max, you'd just be like, you almost say, yeah, you did. But they don't talk
Be more quiet today, that's all. You're more quiet today. It's new. You're usually very talkative. It's good. I like this. I like this new Ian. You're learning, quiet, and you're improving.
Yeah, I didn't.
Oh, it's just the 176.
Yeah, I know this.
It's just a.
Yeah, but it was in the 176. Yeah. It's when you went to the key change, the hierarchy, it's right towards the end there at the end of the trailer. West Virginia.
Yeah. So many people. Oh, wait. So I want to know about West Virginia, the state.
Well, I mean, it's not a state, but right there.
Go on. West Virginia, the state. West Virginia and West Virginia.
The only states that are in cardinal directions are North and South Dakota and North and South Carolina.
Yeah. When they do that?
1776.
Yeah, so there's North Dakota, South Dakota, North Carolina, South Carolina, Virginia, and West Virginia.
But East and West Virginia.
Nice. And it's basically going south. They're like all
Oh, but one belonged to the West. Like, as in, British. Even though you better south, but the British ones,
It's probably it was probably like afterwards. Like Virginia, and then when they got West Virginia, like, well, we already have Virginia.